Welcome to How to Read a Protractor. This is a protractor, and we use protractors in order to measure the angle of angles, the degrees of angles. And there's several steps. Step one is that we can estimate whether or not our angle is acute, right, or obtuse. And we know that a right angle is 90 degrees. We know that an acute angle is smaller than 90 degrees. And an obtuse angle is greater than 90 degrees. One of the ways that we can really quickly estimate which one of the angles ours is by using the corner of a piece of paper. Even something as small as a Post-it note works. And what you want to do is take the corner of your paper or your Post-it note and put it in the vertex of the angle. And see, this one is greater than the corner of our paper, so that means it's an obtuse angle. If I try and line this up in the corner or the vertex of our angle, it covers it over. So it's smaller than that corner or a right angle, so it's got to be acute. And in this case, the angle, corner of our paper, measures up perfectly with the vertex, so there's a likely chance that that's right, a right angle. Okay, our second step when we're using our protractor is that you want to take the circle on your protractor, which is in the center of the bottom of the protractor. There's a little tiny circle down here, and you want to line it up with the vertex of your angle. Okay? After I've done that, my next step, step 3, is to line up one of the rays with the bottom lines. On either side of the circle that I've lined my vertex on, there are little tiny black lines, and I want to make sure that I place that line on the line of the ray of my angle, one of the rays of my angle. The other thing to make sure is as this line extends, you'll see that it actually would be drawn all the way across, that the end of my ray is still lined up on that base line, that bottom line of your protractor. Okay, now I need to read my protractor to know what degree my angle is. Okay, this can be kind of confusing because there's two sets of numbers on your protractor. But it's designed that way so that you can read it whether or not your angle is open from the left or to the right. So sometimes your angles will be open from the left and sometimes your angle will be open from the right. And your protractor is designed so that you can read it either way. Just know, though, that if you happen to have your numbers on your protractor are upside down, your protractor is upside down. So if 90 is reading backwards, just flip your protractor over. Okay, I want to make sure that my circle is lined up with my vertex of my angle, and my lines are lined up on my ray all the way across before I can read it. Okay? But the thing that I can do to help myself to know which set of numbers I'm going to look at, because one set is increasing. This is going from 10, 20, 30, 40, 50. This is decreasing, 170, 160, 150. And the way I can decide that is to ask myself, was it acute or obtuse? So when I remove my protractor, is this greater than or less than 90 degrees? Well, I can tell it's obtuse. So my number better be greater than what? Greater than 90 degrees. So I've got it lined up. I can look at it and see that it's obtuse. So I know it's got to be greater than 90, so I'm going to be looking as I'm opening up, as my angle is opening up. That's another way that you can look at it. Which way is my angle opening? So let's say that I've got my angle, my vertex is over here on opening up to the left-hand side. That means that my angle would be progressing or opening this way. So I want to read my numbers increasing in this direction. So if I look at it from that standpoint, I've got 10, 20, 30, 40, 50, 60, 70, 80, 90. I know it's greater than 90, 100, 110, 120, and the line goes through 130 degrees. So I know that my angle is 130 degrees, and that matches with my prediction that it was obtuse. Challenge you might come across is, what if the angle measurement is between two numbers? Okay, it's not always going to line up exactly on a degree that's labeled. So you'll notice that a lot of the lines do not have numbers. So what do we do about that? Well, I'm going to follow my steps. I'm going to put my circle on from my protractor on my vertex of my angle. I'm going to make sure that my line is lined up on my ray. I can see that this is greater than 90 degrees, so I know that I've got to be with the larger number. Okay, so the line that my second ray is going through is greater than 110, but it's less than 120. So each one of the little tiny lines stands for 1 degree. So it's about 3 degrees past 110. It's getting bigger than 110 by about 3 degrees. So that would be 113. Now, in this case, my angle is opening from the other directions, opening from the right. But my steps are still the same. I'm going to make sure I take my circle and line it up on the vertex of my angle, and I'm going to make sure that my ray is lined up with the line straight across on the bottom of my protractor. And I know that this angle is smaller than 90 degrees, so it's acute. So I want to make sure that it's smaller than 90. So I'm going to look at the inside numbers, 10, 20, 30, 40, and it's actually almost at 50, but not quite there. So it's about 1 degree shy of 50, so we're going to call that 49 degrees. Another challenge that you might face is they might give you an angle that is too small to be read by your protractor because the rays are not long enough. Well, the good news is the bottom of your protractor can be used as a straight edge. So you can use the edge of your protractor to extend your lines. You just got to make sure you're really careful and line it up exactly so that you don't change your measurement. Okay? And now that my lines are long enough, now I can measure them using the same method. Circle on the vertex, lines on the ray, and this is almost exactly at 80 degrees, maybe a little bit shy of that, so 79. Also, every once in a while, you'll come across a protractor that does not have a hole. Commonly, when that's the case, what you really see there is intersecting lines, perpendicular lines, and where those lines meet, you would use just like you would the circle on a protractor that does have one. And you take those intersecting lines, and where they meet, you'd match that up to the vertex of your angle. And just like with the other protractor, you want to make sure that that baseline is on your ray. And then you would measure it just like you would any other protractor. And lastly, what am I going to do if I have to use an online protractor?
Okay, so sometimes you're going to see a question on the computer that looks like this, and they're going to ask you to measure the angle. You want to go up and capture your tool, your protractor tool, and you're going to click and drag it. Same rules. You're going to line up the circle on your protractor on the vertex of your angle, and then you can rotate the line by these little arrows on the side. So I can go either direction, really, as long as I've got the black line lined up on my ray. And then I can measure it, and I can tell already I need to estimate, is it acute or obtuse or right? It's definitely greater than right, so it's got to be obtuse. So I'm going to look at my larger numbers. I come over, it's in between 140 and 150. I can see that the line for 145 is right above my line. So this line is right below it, so it's about 146. And so then I would just type my degree into the box.